I want to solve an initial value problem involving a vector function and an initial condition. But first, let's remember that we've solved initial value problems like this before. And the approach was to find an antiderivative, the most general antiderivative, and then use the initial condition to find out what arbitrary constant solves this actual situation. Plugging in a 0 for x reveals that c really had to be a 3, and now I know that this function is the only one that solves this particular initial value problem. Our approach is going to be exactly the same for this vector function. So I need an antiderivative, the most general antiderivative. For the I component, 1/2 t squared plus t plus c1. In the j component, the antiderivative of tangent is the natural log of the absolute value of secant. If you don't remember the antiderivative for tangent, you can actually establish that by rewriting the tangent as a sine over a cosine and then doing a u substitution problem. The antiderivative in the k component, the antiderivative of sine is minus cosine t, and I need a plus c3 for the k component. I've run out of room there, so I've written the k. It should be right there. Okay, so I have a c1, a c2, and a c3 I need to find. Another way of writing this down would have been to write down the antiderivatives without the arbitrary constants, and then at the very end, plus a constant vector c that would have been equal to c1, c2, c3. I like writing down my initial value problems like this because what I'm doing now is basically working 3 different initial value problems like the one I did before, right? Because now I know that when t is equal to 0, the I component is supposed to be equal to 5. So putting in a 0 for t reveals that c1 has to be 5. Plugging in 0 to the j component, I'm supposed to get out 3. The secant of 0 is 1. The natural log of 1 is 0. 0 plus c2 is supposed to be 3, so c2 has to be 3. And here in the last component, the cosine of 0 is 1, so I have minus 1 plus c3 is supposed to be equal to 5, so c3 is equal to 6. To solve an initial value problem, I do need to write down a final answer. So my function would have to be 1/2 t squared plus t, and then c1 was 5, plus the natural log of the secant of t plus 3, and then finally plus the opposite of cosine t plus 6 in the k component. And there's my solution to my initial value problem.